Okay, this video is demonstrating how to simulate an IR spectrum by using Siam quantum. Okay, so we start with using Avogadro to build up a carbon dioxide molecule. So we need carbon and with two oxygens doing double bonds on the carbon. Okay, so after we do extension, optimize geometry, and then we need to save files in two formats. Okay, so the first format we do is we are going to save it in the XYZ file. So we go to the Siam quantum folder, we create a new folder, maybe we call this folder the IR, okay, and change this file type to XYZ, and we just say that it's the CO2 XYZ. Okay, so this is a starting structure for running in Siam quantum. And for the other type of the file, we say we are going to use the Mo2 file, in which we are going to use this Mo2 file for creating a topology in order to calculate the IR spectra. Okay, so now we are going to save CO2.mo2 within the IR folder. Okay, so now if we check out in your Siam quantum and IR folder, you should come up with the two files. So it's CO2xyz and CO2.mo2. Then we open the browser and search for Swiss param. Okay, and you follow the first link. Okay, so this is the web server for creating the topology for small organic molecules. Okay, then you should find the link to upload the Mo2 file. So we upload the Mo2 file that we built to the server, and we submit the job. It should take some time for the job to finish, but oh, it's already finished. Okay, so you can download this zip file. Okay, and when the zip file was downloaded as a zip, okay, and the file that we are using is the one with PSF format. So if you look at the file type, it should saying PSF. So we are going to move this into your IR folder. So now you have CO2xyz, CO2mo2, and CO2PSF. Okay, and now we go to the next step. Okay, so if we open this PSF file by the Notepad++, okay, so what you see here, they are the coordinates of the molecules, and then we have the numbers over here, which are the Mulligan charge. But this is not the most exact Mulligan charge because it was predicted by classical method. Okay, so what we do here is we are going to use the Siam quantum to do the geometry optimization of the CO2 molecule, and we are going to calculate the Mulligan charge from that. Okay, so here what I do is I type sq.exe and I get the IR backslash co2.xyz for the xyz file that is in the IR folder. Then we call for the basis set again, and we choose the option optimization. Okay, and we are going to output the file into the IR folder, and I'm going to name the file optimization.txt. Okay, so now the optimization has been performed, and you can try to view the result by typing start notepad IR backslash optimization.txt. Okay, and here's what you get. Okay, we can Control F to search for the keyword molecule. Okay, and here we are, molecule population. Okay, so you can see that we get a little bit different number of molecule charge calculated from CM quantum. So it's a little different from the one that you get from the PSF. Okay. So what we do here is we can copy and paste to update all these molecule charge values. Okay, here we are. So we did that for carbon, then for oxygen. Okay, and then we save it. Okay, so now you have the updated version of CO2 PSF. Okay. And then the next step is we are going to run a quantum molecular dynamics simulation for the carbon dioxide molecule. So if you type sq.exe, what you see are the options for running the CM quantum, especially at the bottom we got the option for running quantum molecular dynamics. So we start with sqxe and we choose the CO2 XYZ as a starting structure again, and we choose the basis set. Okay, and then we are going to use the option QMD, and let's look at the options in QMD. Okay, so we are now going to add the temperature of 300 Kelvin into simulation. So I choose the option keep temp 300. Okay, and also I'm going to select to add more simulation steps. So I set the minus QMD max to, this time we just gonna do 250, but you can run it for longer if you want to get more samples. Okay, and I say minus trash equals IR slash trash dot XYZ. So this is gonna output the trajectory file XYZ within the IR folder. Okay. Now we are running the QMD. Should be taking a while. Okay, so actually you should wait for it to finish, but if it's not finished, you can still see the output file here as a trash.xyz. Okay, and in order to view this file, okay, so you use VMD, but this time don't just load the trajectory file into the VMD at once. Okay, so what we need before is the information from the PSF file. Okay, so what we do first is we are going to load the PSF file to VMD. Okay, finishing. Then you come to the VMD main and click at the zeroth molecules and right click, choose the option load data into molecule. And then we are going to upload the trajectory file XYZ on top of the PSF file. Okay, and if we click load, the trajectory will be loaded. So now it has finished by 176 frames so far, so we are okay with it. Okay, After that, we play with the graphic representation for a little bit, choosing CPK and adjust the sphere resolution, and we can adjust the background color to make your simulation looks brighter. Okay, and if you click play, you are going to see the vibration of your molecule. So you can see that there are the mixtures between um, the stretching and the bending.